Okay, so today I'm doing a lightning talk and a live demo, which is like going to Vegas and gambling with the last $2 you got, and I already lost one. I don't have a display up here to drive my demos, so this is going to be real interesting. So please play along with me. Okay, so before I get into talking about Viper, or how to use it, or why to use it, I wanted to stop and say thank you to the folks behind the Viper project. So it turns out that if you write blue team open source stuff, you don't get the $10,000 bug bounties that the security researchers do for O-Day. So this is my way of giving back to the community. If you're not already aware, Claudio Guarneri, bot herder, who's also the man behind the Cuckoo Sandbox project, Kevin Breen, Rafael Vina, Alexander Yeager, and about 24 other folks who have their name on the GitHub commit are the folks that make the Viper project possible. So a little bit about Viper. What is Viper? At its guts, it's really a repository and framework for doing static file analysis. It has definitely a malware event. I definitely have a malware event in how I use it and why I use it. But you can use it for just about any type of static file analysis. Its guts are Python and SQLite, which is nice because it makes it real lightweight, easy to deploy to just about anything you want to run it on. And it's got a fairly straightforward architecture. So it has a web UI, which makes it nice for your entry-level analysts. It's got a Metasploit shell-like command interface, which is my favorite. I don't have an adapter, otherwise I'd show you. I don't have any bars either, but I am in Viper constantly on my phone. I have probably the greatest job in the world, so as a result of that, I get interesting alerts sometimes, and I'm able to triage files quickly from a server in Amazon, from my phone with Viper, and then send emails down to the event analysts and go, hey, I didn't know you caught this, but you should really go look at this, and it's a lot of fun. Kind of the middle stack, the software stack, is the framework code itself. The framework also offers up a series of REST APIs, and it's got a module interface. They made it really, really easy, and we're going to show off all this stuff in a little bit of depth here in the demos. Made it really, really easy to write your own functionality for the Viper framework. So if Viper doesn't do something you want to do today, if you can hack it up in Python, it takes you 8 hours to hack it up in Python, then in 9 hours you can have it as a Viper module. It's pretty easy to set up and deploy. And then the underlying, there's a file store where all of the binaries that you check into the projects go, and then a SQLite database that handles all the metadata and indexing. So part of what was driving my desire to do a talk on Viper is what I'm calling the zoo use case. Because I don't want to come up here and say that Viper is the best static analysis tool in the field. In fact, it's probably not. You probably wouldn't use it as your primary go-to, and certainly not your only go-to for malware analysis if what you were doing was single file, single incident triage and analysis of one file. Right? There are lots of individual tools that are better, faster for particular pieces of the puzzle. But what the framework really gives you is the ability to take and build a history of the malware that exists or that you found, either through information sharing and intelligence gathering from other sources, as well as what you find in your own environment. And what's cool about Viper is, and I'll show this off in a minute, is just like blogs, or is anybody using Confluence or Jira at work? DevOps, all the things, right? You can tag posts, and you can tag people in posts. Well, Viper has a tagging functionality that lets you define what metadata is interesting to you and then assign it to a file, and then go back and search on it, right, like your own interesting indexes. So you might do that by variant, you might do that by when you found it, or you might, like, I'm obsessed with import hashes right now. I'm going to show you the value of that in a minute. So where Viper really has an opportunity to kind of move the ball forward, though, is the ability to analyze, tag artifacts, group them together, and then iterate through those, and then learn. And because you've got them in a repo, if you learn something 6 months from now, you have the ability to build analysis capabilities into Viper and then go back and reiterate over your entire collection. And the reason that I call this the zoo effect is, have you ever been to the zoo and seen the animals and you notice the signs where they give, like the Latin, the genus and the species names? Right. The idea is that we want to start building a lot of data around the relationships between different pieces of malware. Because if you've been doing malware analysis for any length of time, you've come to understand that bad guys are lazy, and the people that build malware and sell it to bad guys are even lazier and greedier than the people that use it, and so it's all just reused code, right? I mean, there's some new bespoke malware out there, but increasingly, right, we take this piece of functionality from over here, from Zeus, and this piece of functionality over here from Dridex, and we slap a new piece of C2 on it based on something we saw from GhostRat, and we iterate through it, and we put it out as a whole new thing, but it's really not all that new. And so this becomes a way over time to start discovering those connections in your environment. And there's some interesting things to be learned, and some quick ways that we can do some of that stuff. So that was really all I had to say about Viper. Now I just want to show you demos. Woohoo! Right. So roll out the flaming hoops and the typewriter in a second here. All right. So first I wanted to kind of show off the sexy web interface that Kevin Bruni wrote for Viper. This is really slick, just because it's hey, personal virus tool. So we're going to try and first I'll just scroll down into, so you can see the repository, so some basic functionality on the front page. The web UI, by the way, if you're doing anything with Yara development, this is fantastic because you can take a large number of samples of malware that you already know all the information about, and if you're doing Yara rule development, leverage the mouse. There we go. Okay. And so come in here, build your rules, edit them. It has the functionality from the artifact to edit in line. And then you actually have a plugin by which we can run Yara rules over a sample. You can also go back through and look at all the different pieces of malware that have been uploaded into the repository. The database by default keys on SHA-256. This is useful to know when you're working with the API. If you want unique identifiers by session, knowing the SHA-256 value of a file is the key you use to interface with it. I'll show that out in a minute. And over to the right there, you can see some of the tagging that I've done. So these values on the right, these are all import hashes, right? So everybody familiar with PE and hash and how value calculation works for that? We take all of the imports from the PE header to the binary, generate a unique hash. And so this is like it's an MD5 value, but it's not just the MD5 of the file, it's the MD5 of a certain subset of the contents of the PE header. And it's interesting because it gives us some idea of how the file intends to run when it gets there. And so normally you would think, well, this is a packet executable, it's obfuscated, it's not all that unique to things, but I keep seeing this in hash over and over and over again. And what's interesting is if we go through, this is across several different types of variants, right? Some of the stuff is POS related, some of it's NJRAT, some of it's Nanopore, so on and so forth. So, if nothing else, right, that gives us some idea that there's some relationships there, at least to how the binary is getting packed, and that might be really interesting, right? Typically, we look at MD5 values as being somewhat low value, right? In terms of it's trivial to take the exact same raw binary, repack it, get a new MD5 deployed. But but so some of these other static values are proving to be a little bit more persistent and reliable for detection. So let's upload a file. Oh, we should know. Or we got some. So now we can. By the way, if you want samples, stop by. You can trade malware, you can try to get me out. One of the things that they did, by the way, I love this. This is so culturally appropriate. Everybody, so what's the password to my zip file? Infected, that's right. But so I love the fact that they thought that through, though, right? Everybody hands the malware samples around the zip files. So that upload happened relatively quickly. You can see it here. And now I can drill into this, get all sorts of information about it, get a breakdown. I can start tagging it in here. I have installed PySSD. So for those of you that are familiar with fuzzy hashing, I can do a fuzzy search and see if there's significant matches. It's not working. That's all right. I'll show you later. And then we can go to the modules, and we can execute individual modules. So maybe we want to see. It's really hard to drive over my shoulder. Sorry. So for our PID, right against the file negative. So this is the web UI. The other thing that is pretty cool about this, and I won't demo it for you, but highly recommend it. Right? So I mentioned earlier that Claudio, one of the key developers of Viper, is also the guy behind Cuckoo Sandbox. Cuckoo integration is built in, so if you've got Cuckoo Sandbox running, go ahead and put an endpoint config into Viper, point it at your Cuckoo server, and you can go ahead and take samples directly from your Viper environment, run them through Cuckoo, and then it will tag the result in Viper with the Cuckoo report. So it won't actually re-import all the report data from Cuckoo, but it will give you a quick link. So if somebody's already running through the sandbox, you can go back through and view it later. Right? So it gives you a nice triage desk to work from for those artifacts. And lets you do one web interface to do both your static and dynamic analysis. All right. This is the command line interface for Viper. This is everybody's going the kind of Metasploit shell route. I really dig this though. I use it a lot. Typing one in here so I can go through all of my this stuff in my repo. File. And then I can do interesting things like XOR search. Can you find anything? Yeah. And the reference to HTTP, that's probably a false positive. This is another one I really like. Search string dash capital H will go through and look for anything that looks like a host FQDN or IP address hard coded in binary, because that's usually a good indicator that something fun's going on. All sorts of things that we can do. I'll come back and demo a couple others in a minute. So let's switch briefly to code. So I mentioned earlier that Viper's got a modular interface that lets you write your own modules. This is a really, really simple kind of hello world version of it. So I don't actually bring in any outside code from beyond what the Viper framework is already capable of here. In fact, this functionality of file.type is readily available inside of the info screen that I showed you earlier. But let's say you just wanted a command that all it did was give you the same output as if you were running file from a command line. Just get the file output. Can everybody see this, by the way, or is this hard to see? Good? Okay. So, we essentially reference a couple of basic, pieces of the modular framework, right? We call in Viper comment and core session, work within the session, and declare a module. define the initialization and the run, and that's pretty much it. Instead of using standard print commands from Python, everything goes to a self log, and you can declare which logging level each piece of output has. So that's a basic use case. This is a little bit more advanced use case. Yes, this is. And so raise your hand if you're familiar with PE Studio. I'm not seeing enough hands go up, by the way. So if you do malware triage, your homework for tonight is to go out and download PE Studio 8.5 is the latest release out. PE Studio has to be the greatest static analysis tool for PE header reading available. Free code, really cool stuff. My big problem is that Viper runs in Python. I could port it to Windows, but I love Linux. So I had to go out and recreate my favorite feature, which is the function blacklist. So, one of the things PE Studio will do is read in all of the import functions. I told you I'm a little obsessed with binary imports. And it actually keeps a blacklist. These blacklists are available in XML files. So you can see, I'm going to walk up to the screen, sorry. So you can see there are a couple lines up where it's calling in my that XML file. That's just taken right out of an unzipped version of PE Studio. And what we're doing is we're taking the file that's in the open session in Viper, and we're just walking the PE headers, iterating through them, and then every time we come across an import, we're just searching for whether or not it exists in the blacklist file. And if it is, then we're just reporting that out. So let me give you an example of how that looks. So we can do PE imports, pretty straightforward. Oh, nice. I'm going to have to choose a better session. Nice pattern, by the way, right? Single import. So, but that's really interesting. Most normal files don't have just a single import. Like it says. Okay. So we can get a list of all of the imports, right? So by DLL, here's all the function calls. So that module that I showed you up on the screen, I rewrote, and you can see here it's cross-referenced all of them. So everywhere you see a bang in yellow on the left, you can see we've identified a blacklisted function. And getting an idea of how many of the functions that it calls are blacklisted is definitely interesting. To give you some idea of whether or not you've got a suspicious file on your hands. All right, and for my next stupid Viper trick, we are going to. How about this? Okay, perfect. So I've only got 2 minutes left, so I'm going to skip over running this one for you. But one of the big problems that Viper has is that I just walked you through some pretty manual UIs. What if you had a large number of samples that you wanted to import automated tagging for? So this is a script. You point it at a directory, run this, and this will access the API, which is right here on the top half. Take the individual files, upload them, take a local hash of them, and then reiterate through them, tag them with PE, import hash, and any other tags you wanted to add to them. But for my last trick, get there. Yes, indeed. So my last trick, I thought I would show you how to leverage the API to actually go ahead and build some visual analysis based on what's in the repo. Right, so one of the things Viper can do is it can use SSD to do fuzzy hashing functions against all of the files, well, against any individual file. Well, what if you could iterate through all the files and then using networks, which if you're not familiar is a node mapping library for Python, and build an actual map of these things. So this is fuzzy below. You can see it just kicked the crap out of the API for a minute here. because we're going through mapping relationships and then pulling back all kinds of artifacts out of the repo to build this table. We did. So here we have a node map of all the different samples with their names. It's a little bit messy. I could probably do some stuff with leading and fonts to clean this up. But you can see we're able to map all the different relationships between all the different families. And some of these, it's very obvious why they're related, and other ones, maybe not so much. There are definitely some where the lines get longer, meaning the weight is lower, so that there's some relationship, but not necessarily a solid relationship, suggesting that there might be some code reuse going on. So anyway, a quick and dirty way to get an idea of whether or not items in a particular repo are related to each other using, in this case, fuzzy hashing. So, all right. Last but not least. So I'm going to open source all this stuff. But this is my dirty ploy to get over 1,000 Twitter followers. I'll be posting this stuff to GitHub on Monday, and the announcement will go out on the Twitter account. If you've got more questions or just want to talk Viper after the fact, this is where you can find them.
Do you have a giveaway?
Trivia question.
Trivia question for a Blue Team handbook?
Okay, sure.
Can you delay red?
Quick trivia question.
Just letting out.
Wait. Okay. All right. So here's a really esoteric one. I named Fuzzy Pillow after another project that's often ripped off in the security community. If you can name either the project or the author of the project, this book is yours.
Afterglow?
It is. I ripped this off from Afterglow. Rafi Marty.